Welcome to another video on convolutions. We did an introduction on convolution in the previous video. Now what we're going to do is we're going to take what we've learned for convolution, which was basically for discrete time convolution, we can find y of n using a convolution of one signal, the input, with the impulse response, which basically means passing one signal through the other. As we've talked about before, it really doesn't matter which, is it x of n, well, h of n, or h of n, x of n. But the bottom line is, for every value of n, we are able to use this equation, this relationship, which is called the convolution, to find y of n. So convolution. All right, and in convolution, mathematically, how we represent this is that it is a summation of k, which is another new variable we are introducing, and is the only variable in the summation from minus infinity to infinity. X of k, which is the x of n, basically replaced the k, n with the k, sits there, and then we're going to take the impulse response n minus k. As n increases, you will see that h moves to the right if you were graphically representing. As we discussed in the previous work, you can do this purely mathematical, and we'll get there and do that, but it's kind of hard to understand what y of n really looks like if you do pure mathematical until you actually get the mathematical equation resolved and plotted. The other one, which we like to use as a way of learning, is to use this graphical or intuitive approach, which is kind of our focus here. As you can see, is the graphical or the intuitive approach. In the next slide, we'll try to put the mathematical method to work, but for this is it. So as we start looking at this, it's important to be very systematic if you're using this approach. And the first thing you gotta do, you gotta draw x of k. And in this particular case, let's go ahead and draw that. So instead of the horizontal axis being n, we're going to replace it and call it k. The reason for that is because if you look at this equation, we want x of k to stay constant, but we want h to move as n increases, and we're trying to find the different y of n. So let's go ahead and see if we can go ahead and take x of n. In this case, x of n input is this equation here. If you can kind of plot that, if you do that, we'll know that y of n says that the value of x of k would be 2 starting at 0, because the rule is that the step response u of n is equal to 1 when n is larger or equal to 0. So this will be the first time is non-zero. Of course, if you go to minus 1, it would be 0 and all the way back. Now, this will continue to 1, 2, 3, until let's go until 9. And if you go there, we'll see that, okay, this is 2 because the step response n, anytime n is larger than 0, is going to be 1. So we're going to get a bunch of 2 values of 2 on x until we arrive at 9. Now what happens at 9? Nothing. At 10, you notice that at 10, u of n minus 10 will come on, but it's a negative, so it's going to get subtracted, which means at 10, this goes back to 0, and then it stays that way forever, and the same thing over here. All right, so we've got our x of k figured out, and that is basically a kind of a goes to 2 at n, k equal to 0, and runs all the way through. So all I did for x of k was replace k, n with k. Now h of n minus k is a little bit more complicated. So what I'm going to do, so I'm going to start back here, because I eventually would like my to be able to draw my h of n minus k so I can kind of see how the relationship between the two is, because what I'm trying to do for every value of n, I want to evaluate this equation. So let's see how it goes. So to break it down, because n minus k could be somewhat complicated to do, so the way I'm going to break it down, first I'm going to draw h of n, just replace n with k. So let's go ahead and see what happens. Okay, I'm going to use green because I'm not going to use them directly. So h of k is simply going to be u of n minus 2 minus u of n minus 5 times 4, which means it's going to come up at 2. It's going to be 4. And then at 3 is going to be 4. And at 4 is going to be 4. But then once it gets to 5, u of n minus 5 comes alive, but it's a negative, so it's going to subtract out and goes away. So at 5 will be 0 and forever. And this axis is k, and these axes are the 1 and becomes 0 all the way back to minus infinity. All right, but that's not what I'm looking for. I'm looking for h of n minus k. So the next thing I'm going to do, I'm going to draw h of minus k, which is just going to be the same as that. The only difference is going to be that my values are at minus 4, right? You mirror it around the 0 or mirror it around the vertical axis. So you're going to end up with, or you replace k with minus k if you want to think about it that way. So you'll end up in minus 4, minus 3, minus 2, and these guys will be values of 4 here. Okay? And then the next step, all I have to do is basically take this, redraw it, and typically we redraw it, pull it all the way back such that there's no overlap so we can start clean. So we basically are starting with n equal to minus infinity. We can't draw minus infinity, so we started way back on the left-hand side of the screen and then work our way in. So this one is going to be basically, we have n minus 4 at 4. And then notice all I'm doing, I'm putting an n in front of these things, right? That's all I'm doing. So n minus 4, n minus 3, n minus 2, and the rest of the stuff is 0, right? And now graphically I have been able to kind of look at this thing and be able to tell kind of where h of n minus k is non-zero and where h of k is 0. Now all I have to do to find all the different values of y is to keep kind of moving this n forward. So let's go ahead. I'm going to erase this now that we know how to do that portion of it, and I'm going to use this space to do some other stuff. So now I'm getting to trying to figure out what are the intervals that give me common equations for my y of n, because that's my goal. My goal is to find y of n. One thing I notice is that as long as n minus 2 hasn't arrived at here, at 0, then I have no overlap. So all I do, I say, okay, as long as n is less than 2, right? As long as n is less than 2, then what you got going is that your n minus 2, 2 minus 2, or if n is less than 2, this number will be less than 0, so it hasn't arrived at this point. So in all that interval, basically you have no overlap. There's no way you can take an x of k and multiply it by h of n minus k to sum it. All of them, either x is going to be 0 or h of n minus k is going to be 0. So the multiplication will be 0. So for this interval, which is this interval is referred to as no overlap, then y of n, which again I just want to remind you is this summation, but the fact is either x is 0 or y is 0 as long as n is less than 2, which means y of n summation is going to be 0. Done. So if somebody walks up to you and say, what is 1 of minus 1, or 1 of 1, or 1 of minus 5, your answer is it's 0. Done. Your output is known. System is now defined when n is less than 2. Now what happens when n is bigger than 2? Well, then you're going to see when n gets to be 2 or bigger. So one other nice thing is once you've defined this, your next interval is going to be where you left off. So you left off at 2, so you're going to start n at there. Now the question, what happens? If you look at this thing, n minus 2 comes in here, and that's called a partial overlap, because there's a little bit of overlap, but there is stuff hanging this way for h of n, and there is stuff hanging that way for h of k. There's no full overlap. So we're going to, this is referred to as a partial overlap. So let's go ahead and do that. Partial overlap. So in this case, now we got to find out what y of n, or where does the partial stop. So the partial will stop when this n minus 4 arrives here. Notice, and I'm going to do something. I'm going to start moving this so we can kind of see what's going on. So let me redraw this one more time. And let's see if I can grab it and move it. So that's basically what I'm doing over there. Take this guy, if I could. Maybe that's more than the system can do. So I'm going to grab this guy and move it to partial. And you notice here, I'm almost got a partial, but the partial finishes when n minus 4 arrives here. Now all of x is overlapping with h of k. So for the partial, we want to make sure that n minus 4 doesn't arrive at 0, because once you arrive at that, we have full overlap. So n minus 4 has to be less than 0. So that basically tells us that n has to be less than 4. Oh, I need a pen. Less than 4. Okay? Now, so what is y of n? So y of n, basically, it's going to be this equation right here. Okay? Some modification. We don't want it to go from minus infinity to infinity, because if you look at the partial overlap, the highest overlap or the lowest overlap happens at when 0, whatever 0 is. So the summation is going to be summation of k equal to 0. Where does it stop? At the end of this, because that after this there is no overlap. So it's going to be n minus 2. And then what is x of k? X of k is simply 2. What is h of k? Well, we already know what h of k is. H of k is simply, I don't know what happened here. So let me clean this up to make sure it says the right thing. This is n minus k. So we start at 0, we end at n minus 2, and it's 2, x is 2, and h of n minus k is 4. So this simply becomes summation. Oops. Oh, sorry, I must have jumped around. Let me go back to this again. There. Okay. So now we are here, and this just you can rewrite it or just leave it the way it is. You can just say summation of k equal to 0, n minus 2, 8. So that's great. We are almost done, and if somebody wants us to find n equal to, let's say 3, we say okay, n is equal to 3, so that's going to be k equal to 0 to 1 of 8, and you just calculate that summation, and you have the answer for y of 3, let's say. Okay. Now, next one is basically 4 was where you stop, so we're going to start the next interval as 4, and this is going to be full overlap. Oops. Overlap. All right, so n is going to start at 4. Now the question is, what happens at 4? When n is equal to 4, then this is going to be 0. So lined up right here with the 0. and there's full overlap, and that full overlap will continue until n minus 2 leaves 9. So as long as this thing is less than 12, so when n minus 2 arrived at 10, right? As long as n minus 2 is less than 10, we have an overlap, full overlap. And after that becomes partial overlap because part of the x has moved off that skin. So now what we've got a y of n, except for this time, regardless of, so we can write the summation. So the beginning of the summation is going to be n minus 4. End of the summation is minus 2 because outside of this x is going to be 0 regardless of what h of n is. And we know these are always so. So it's going to be 8. But you always see that n is not in here. So if you evaluate this from k equal to n minus 4, minus 3, minus 2, you're going to end up with 8 plus 8 plus 8, which is 24. Great. Now the question is what happens in the next one. Next one, what's happening is that your h of n minus k now has moved, and let's see if I can try to move it. So see if it can make it work. So this has moved to a place where now part of it, this part n minus 2 has already left, is either at 10 or higher, but the back end is still there. So when is it that the back end will leave? Well, if an n minus 4 arrives at 10, then there's no overlap, right? They're past each other. So again, the beginning, you know where you end. So the beginning starts where you ended. So beginning of this one starts at 12. So this is going to be partial overlap. And then where does it stop? Well, it's going to stop when n minus 4 arrives at 10. So as long as n minus 4 is less than 10, then we're in partial overlap. Well, n minus 4 less than 10 means n has to be less than 14, right? So that gives us that interval. And y of n here now is basically going to be summation of k. Know the back end that is overlapping is n minus k. So k at the bottom has to be n minus 4. The top is always going to be 9. So 9 stays here. And then this is again, it's going to be x of k times h of n minus k, which is going to be 2 times 4. And we are pretty much set. K equal to n minus 4 to 9, 8, and we're all set. Now, one last thing, what happens when this completely moves out? So you've got to a place where you have no overlap now again, which means n is larger or equal to 14. So this back end of this thing has already moved out of your x. And then this side you can leave alone, or you can just say it's less than my plus infinity. It's up to you. Much like here, you could also put less than or equal to infinity if you like to be complete, but it doesn't necessary, because if it's larger, n is larger or equal to 14, infinity is, and that's the same thing as saying it's less than infinity. Anyway, so this basically, there's no overlap, which means that all the summation is going to be summation of something times 0, which means y of n is equal to 0. Okay, this we like as a graphical representation, because you can clearly, anytime somebody can ask you, okay, well, tell me what y of, let's say somebody comes up to you and says, okay, what is y of 5? You say, okay, that basically tells me that n is equal to 5, right? And okay, where is 5? 5 fits right in here. So this is the equation I need, which means is always 24, and I'm done. Let's do another one that we have to do a little bit of work on. Let's say someone comes up to you and say, what is y of, let's say, let's do another easy one, 50. So they want to know when n is equal to 50, what's the value of your output? And you say, okay, 50 fits in here, value of my output is 0. Okay? Now, I'm getting carried away, but let's do one more. And let's say someone walks up to you, and I don't know why would they walk up to you and ask silly questions like that, but maybe they do. And then ask you, okay, what is y of, let's say, 13? All right, if it's 13, that means n is equal to 13, which means this is the interval I'm really focusing on, which means the equation I have to use is summation of k equal to n minus 4, which is 13 minus 4 and 9 and 8 is that. So that basically says I have a summation of 9 to 9. K goes from 9 to 9, so 1, 8. So that means it's just 8. Okay. So what we've done here in this particular one, we started with a problem, and our goal was to use a graphical or intuitive approach to it. We're using convolution. Convolution always relies on the sum to get the job done. So regardless of what goes, this is the sum we want to use. And the graphics, what the graphics does allows us to break the function into pieces that are can give us a y of n with one equation or one value, instead of us having to create piecewise or create a very complicated mathematical equation to describe it. We graphically show what it is. In the next slide, you'll see what a graphical, if I don't use the graphical method, what my equation would look like, okay? And then it's a little harder to figure out what the values of y of n are, unless you use a computer or something to graph it for you or work through the mathematics of it. So, and then in order to graphically do this, we understand that this equation is basically saying that I'm going to sum the multiplication of x of k and h of minus k as n moves, as n increases, which means h of k is moving down this path, okay? And let me get rid of this. So that's kind of what's going on there. And if you remember, I kind of recommended that when you do this, just make sure that you first draw h of k. So you really should do this in 3 steps. A, do h of k. Next step, do h of n minus k, which is flip it around the vertical axis, and then come back and just add an n to every location that you have, so you would get h of n minus k. And that's the graphical method. What you're going to end up with is intervals. This is as complete as you can be. No overlap, partial overlap, full overlap, partial overlap, no overlap. Now sometimes you have signals that go from minus infinity on, or from minus to plus infinity. In those cases, you just have one interval and you're done. Most of realistic systems we work with start at a point, finish at a point, so you got to kind of pay attention to that. And then of course you saw, once I have my y of n for various thing, anytime I need to know what y of n is at any point of time, or point at any sample point n, I can just plug it in, find out which interval I'm in, and use the equation to figure it out. That brings us to the end of the graphical method for the discrete time.